By now, we've talked a fair amount about absolute value functions and how to transform their graphs. What we're going to get into now is how to solve an absolute value equation. And the best way to do that is just to jump right into it. So, in order to be able to solve an absolute value equation, it's really important to understand the concept of an absolute value. Absolute values represent the distance that something is away from zero. And as you already know, distances cannot be negative. So what that tells us is that the absolute value of an expression will always be positive or it'll be zero. It'll never be negative. And that's really important when it comes to solving an absolute value equation. The first step in solving an absolute value equation is to make sure that the absolute value itself is isolated. So if I look over here, I can see that on the left side of my equation, all I have is an absolute value expression. I don't have a coefficient, I have nothing added or subtracted, nothing like that. So I can actually go ahead and jump to the next step. And the next step is to use the understanding that the absolute value of any number is going to end up giving me a positive number. And since I have absolute value of x minus 4 inside the bars and it ends up giving me a positive 6, that tells me what's in the bar could be equal to 6. So I could say, well, x minus 4 could have been equal to 6, but you know what? It actually could have also been equal to negative 6 because the absolute value of negative 6 is also 6. Once you get those two equations, you just go solve them. I'm not going to spend a ton of time on these notes practicing solving equations. If that is something you need help with, then you definitely need to approach your teacher about that so they can help you, because it is critical for you to be able to solve an equation properly in this class. So be sure to reach out to your teacher if that's an issue that you're having. So once I'm done solving, I can see that I have two different solutions. I've got x is equal to 10 and I've got x is equal to negative 2. But there is something you must do whenever you're solving absolute value equations, and that is to check your work. And this is not one of those check your work like, oh, my teacher wants me to check my work because we want to make sure we're doing it right. Yeah, of course we do, but in absolute value, it is even more important that you check your work because you might have something called an extraneous solution, and you want to check for extraneous solutions. And an extraneous solution is basically a solution that you get, but then whenever you substitute it back in, it ends up creating a not true statement, which means it was a solution that does not fit my equation in the first place. It is not something that I can say is part of my solution set. And the way you do that is the same way you check any other equation, is by substituting back in. So I'm going to start with, instead of x, I'm going to substitute in my 10 from my first equation that I solved, minus 4, and I'm checking, does that equal 6? And when you simplify it, you end up getting 6 in the absolute value bars equals 6, and that is of course true. The absolute value of 6 is 6. Do the same thing to the other side, but this time I'm going to substitute in my other solution, negative 2. And negative 2 minus 4, I want to check, is the absolute value of that equal to 6? And actually it is. I end up getting a negative 6 inside the absolute value bars. And as we just discussed, the absolute value of negative 6 is also positive 6. Now here's the really cool thing. If I were to graph this on a number line, if I were to put this on a number line, and let me start with negative 4 a little bit away from my negative 2, and we'll count by 2's. And I plot those on my number line. Notice that these two values are equidistant from this 4. This one is 6 units away, and this one is 6 units away. Huh, look at that. I've got these 6's here. This 6 right here. And notice this 4. And I've got this 4 here. Pretty cool, right? That tells me that it's equidistant away from there. Now you're wondering, well, which of those two is my solution? They both are. So the way that you're going to write your answers, you're just going to say x equals -2 or x equals 10. You could also totally write this in set notation. You could say brace -2, comma 10, close the brace. Totally a valid way to write your answer as well. Now let's talk about what if it's not that easy? What if I do have a coefficient? What if I do have a value added or subtracted to my absolute value bars? Let's see what happens. So I've got 3 times the absolute value of 2x plus 5 plus 10 equals 37. So if you remember, I said the first thing you need to do is isolate the absolute value expression. And in order to do that, you're just going to treat the absolute value as its own variable. So you're going to solve it as if it is a variable, and then we'll break it down. Because while it's inside those bars, you cannot work within it until everything else around it is gone. So I'm going to isolate the absolute value bars. I'm going to start by subtracting 10 from both sides. So I have 3 times the absolute value of 2x plus 5 equals 27. And then again, I ask myself, have I isolated the absolute value bars? And I haven't. I've still got that 3 there. So I'm going to, again, treat it like a variable and divide both sides by 3, which leaves me with 2x plus 5 absolute value equals 9. And again, I ask myself, have I isolated the absolute value? And this time I have. So now I can jump into the 2 different equations that get created. I have 2x plus 5 equals 9, or 2x plus 5 could equal -9. And like I said again, I'm not going to spend time solving these equations with you. Make sure you know how to do that on your own. So if you solve it properly, you will get x equals 2 and x equals -7 for the 2 different equations that have been created. Before you write an or in the middle and box your answer, remember, make sure to check for extraneous solutions. So I'm just going to come up here and check my work. And again, all you do is substitute back into the original equation. 3 times the absolute value of 2 times, my first solution was 2, plus 5, plus 10. Does that equal 37? And if you go ahead and solve, you will see that yes, 37, you get a 37 on the left and you get 37 on the right. Now you should actually go do it on your own, but for the purposes of the video and keeping it brief, I'm not showing it. Make sure to ask in class if it's something you don't understand. And then same thing for the other solution, 3 times the absolute value of 2 times -7 plus 5 plus 10. Does that equal 37? And again, it does. Now, there is one very important thing to note. Well, let me box my answer on the previous one first. Since both of the solutions did end up working out, I can say they are both my solution. So I say x equals 2 or x equals -7. But again, let me remind you, an absolute value expression can never be negative. And so if the isolated, remember, after it is isolated, absolute value bars end up equaling a negative number, that means there is no solution. Okay, so you don't keep solving because you cannot have absolute value equal a negative. Okay, so what if you have absolute value expression on the left and an absolute value expression on the right? What do? Guess what? It's the same thing. I check, have I isolated? And on the left I have, on the right I haven't, but you only need it to be isolated on one of the sides of your equation. And then you treat it the same way, but watch what I do. When I split into my 2 equations, I'm going to drop the absolute value bars on the left and leave the one on the right to be positive. but I'm going to replace it with parentheses because the whole thing was inside the absolute value bars. The other equation I create, watch very carefully. I drop the absolute value bars on the left, equals 2 times the negative version of that 3x plus 1. Because I need a positive version and a negative version. And that's how I do a negative version, because you need that whole expression to be negative, not just the 3x, not just the 1. And then you solve it. I went ahead and solved the positive version of the equation on my own. I expect you to do that as well. And the other side, I will go ahead and show you how to begin it and then again finish it up on your own. On the left, I'm going to leave it as 4x minus 10 equals. And then on the right, there's one of two things you can do. You can multiply the 2 times the negative, or you can distribute the negative and then distribute the 2. Both ways are going to work. I feel like if you distribute the negative first and then distribute the 2, that might make more sense for some people versus others. And then again, you go ahead and distribute the 2. After that, finish solving. So if you finish solving properly, you'll get 4/5 on the other equation. And whenever you check your work, it does end up working out. I'm just going to write a note. Remember to check your work. I did check it. I'm just not doing it for the sake of the video. All right, and the final type of question you might have are word problems. And you guys are like, oh, word problems. Guess what? You're in an honors algebra 2 class. Even if you were an on-level algebra 2 class, you'd still be doing word problems. Okay, in word problems, the way that absolute value is going to work is you're going to be dealing with maximums and minimums, and you're going to have to figure out how to create an equation that's an absolute value equation given different maximums and minimums. So go ahead and copy down this problem that I'm about to write and pause the video, and then we can do it together. In a cheerleading competition, the minimum length of a routine is 4 minutes. The max is 5 minutes. Write an absolute value equation that represents these minimum and maximum lengths. And the way that these are set up kind of deals with that number line that we created on the front, where we had that value in the middle, and then my endpoints were were equidistant from that point. And you can create a number line to do these, especially for some of you that visualization helps. But basically the way that you set it up is you have x minus, where x is like that goal, x minus the halfway mark, and the absolute value of that equals the distance from the halfway mark. And you can find that halfway point, however, whether you create a number line, whether you take the average, whatever it is. So in our case, the halfway mark between 4 and 5 is 4.5. And the distance that both of these are away from the halfway mark is 0.5. So I say equals 0.5. And that is how you set up the equation given minimums and maximums using absolute value. Be sure to come to class with questions that you have so that way your teacher can answer them for you.